Yes. So let me start giving you a short background. The solution we're going to present you today is part of a larger project called DigiBig. And Knowit is cooperating with Statsbygg with this project. And the purpose of DigiBig is to digitalize and innovate new buildings with smart technology so that the residents and the proprietary of the building can utilize the full potential of the buildings as a whole. So let me start by talking about this building that we are in right now. It's a building called Sundkvartalet, and I believe it was finished in 2017. So it's a rather new building. And think about working in a building like this. Let us say that you have a meeting at 12 o'clock in a room called Skogen, and you have no clue where it is because you're new to the place. So what you need is to find a way to know where it is. And either that, or maybe you need to go to the restroom and you want to know if the restroom is occupied, because due to the limited amount of restrooms there are in the building. What if you have an assistant on a display that can actually answer this kind of question for you on the fly? Wouldn't that be awesome? So MagicBoard is a solution that we have created that can help you with these problems. And it works like a dashboard. And it works in a way that you can choose whatever you want to present on the display whenever you want it. It includes many cool technologies like IoT devices, cloud, Google Assistant, and it is an open source project. And the reason it is open source is to allow people to contribute with their cool features and ideas to the platform. And this specific approach is based on another open source project that also Jan Henrik just talked about, Magic Mirror. Like he said, it's a project focusing on the smart mirror platform. And it uses the same system like us. They use a modular plugin system. We actually started using Magic Mirror, but we changed after some time because we found out that it didn't really fit our purpose. So you may ask, why didn't we actually keep contributing to an already established open source platform like Magic Mirror? The reason behind it is due to the technology background that it requires, because the Magic Mirror is customized on a mirror. Our case want to display it on a television. So we don't need all the features that Magic Mirror provides on a television, and also the fact that the Magic Mirror prefer to use the Raspberry Pi to process and host the application. But in our case, we have many other features that require more processes that the Raspberry Pi can't handle. And that led us to our decision of creating the application in React.js instead of Electron.js. And it also opened the ability to open the dashboard from any browser. So here's some of the features that we have. The first one here is the indoor positioning mapping, where you can actually see the different rooms available at the flip floor. Like I mentioned earlier, if you had an appointment at Skogen and you didn't know where it is, you can actually just go by this map, check out where Skogen is, and see where you want to go to Skogen. It is also possible that you can, in advance, know if the room you want to book is occupied or not. Because instead of just going all the way there and find out it is occupied, you can just go to this map and see if it is busy. And if it is, you don't go. And if it is available, you can go and book it. So yeah, and we take no credit in creating this, because this is created by some of our other colleagues. And we just basically embedded this as an iframe into our application. The next one, this one shows statistics of other projects here at Knowit, because we have different projects here at Knowit that we don't, and everybody don't really know much about it. So we thought about providing some of the information that the statistic in the different projects can provide. In this case, we have NDLA and the Global Digital Library, which have data from Google Analytics, and Google Analytics provide a real-time API that we use to display the current active users on the application. So this gives people to get a better insight on the different project when they are not familiar with everything that's going on in Knowit. So this one is, yes, real time. And we have another one. This is the julkalender that was available to be seen during Christmas. It's the yearly Christmas calendar that Knowit has, and during Christmas we could see the updates on how many users were registered, how many solution was sold. So yeah, and the Santa Claus was actually animated, so it was a cool feature. So now we have Espen. He will talk about the cool stuff about hardwares and Internet of Things.
Okay, very good. Yep. So, in a project, we have several external IoT devices connected to our MagicBoard, all with different features. So, the thing they all have in common is they are controlled by a microcontroller, which is the ESP32. The ESP32 is a low-power system-on-chip microcontroller, which comes with Wi-Fi, Bluetooth, as well as it's powered via micro USB, and can also communicate through the USB. In this project, we use the Arduino IDE and the programming language to program our microcontrollers. Arduino is an open source electronics platform based on easy-to-use hardware and software. So let's dive into our devices. So let's first look at our PIR sensor. PIR stands for passive infrared sensor, and is used to detect infrared light radiating from objects in this field of view. So if someone stands in this field of view, it should be able to detect the infrared light radiating from that person. In our project, the PIR sensor is used to disable the screensaver on the TV. This is to save power as well as avoid burn-in, which can be caused by showing a still image for longer periods of time on an LCD screen. So in our case, the screen goes into screensaver mode after 15 seconds without detecting any infrared signals. The PIR sensor is powered and communicates, or through the ESP32, through the USB cable through serial communication. So now I will show you a short example of a code used to operate the PIR sensor through the ESP32 using the Arduino programming language. This is not the exact code we used because we couldn't find it, but it's more or less the same as our case. So you see the important things on the top here is to, because you have to connect wires to the ESP32 and connecting them to the sensors. So just be wary of that you use the same pin number as you use to connection. And in the setup, you define which is output and which is input. In our case, sensor data is input. In this case, they light up a LED light as output. And you also open serial communication with a given baud rate of 9600. So what it does is to the loop, it runs forever, like in a loop. And then it reads continuously the data from the sensor. So if the sensor detects something, then it reports that, I detect motion, and then it writes on the serial port. And if the motion goes away, it then writes that the motion is ended. So the only difference in our case is that we have this delay of 15 seconds so that the screensaver won't blink all the time. So yeah, I will show you a short example of the code used to operate. Now, briefly show you how the serial port is read by our JavaScript application. So our MagicBoard is divided into two different parts. We have a server and a client. The server side does all the communication with our IoT devices, or at least the ones that are connected to a serial, and reads the data from them and then transfers it through WebSocket to the client. And the client is a standalone, or the client is all the modules as well as all the front end. Everything you see on the TV upstairs is basically the client. So the client can work on its own, but if you want to have the motion sensor or control it by smart buttons, you have to have the server running as well. So up to the left here, you can see how we set up the serial port, and we choose COM port and the baud rate, which is also the same as in our Arduino example. And the server, the server connects to the client through WebSocket. So the client subscribes to WebSocket, and then it sends a message, which we store the WebSocket for the given application. And then when we get some data through our serial, like the like the peer sensor, we then write this data over to the client. So then it handles the inputs. Yes. This is our smart button controller. It's built using an empty screw box as the case, with 3 smart buttons connected and an ESP32, which is inside it. The 2 buttons with arrows, they change the view on the screen. And the third one was meant to activate facial recognition in our application, but we removed that feature along the way, or we didn't develop it. And then we have our room measurer. That's a word I came up with while writing this presentation. Our room measurer is an ESP32 connected to a tiny sensor, which measures temperature, air density, and humidity in the room where it's placed. You might have seen some hanging around in the fifth floor. The ESP32 is connected to the Wi-Fi in our office and sends the measurement data from the sensor to InfluxDB, which is a time series database. And then we have Grafana, which then collects data from the InfluxDB and creates a graph, which is shown in its online dashboard. We then display our graph in our MagicBoard through the use of iframe. So I will now show you a short demo on how we use Google Assistant to control our info screen. Okay, Google, talk to MagicBoard.
Okay, here's the test version of MagicBoard.
Hi, welcome to MagicBoard. What can I show you today?
Show me general info.
Showing general info.
Change map location.
Showing next location on map.
Next location.
Showing next location on map.
Show statistics.
Showing statistics.
Show YouTube info.
Showing media info.
Change YouTube filter to cats.
YouTube filter set to cats.
Thank you.
I missed that. Say that again.
Goodbye. So sadly, we don't have any videos which matches the filter cats in our YouTube on our YouTube channel. And there you also could see the peer sensor in action. While it's maybe not the best sensor, but so the screen went black twice during the presentation there. So I'll give you a very short demo on how to set up your own custom actions for Google Assistant. So let's see. Yeah. Okay, I don't see it on my screen, but it can work. Okay, so to start, you have to go on, log on to console actions or actions console on Google. And there you can either create a new project or select an existing one. We will select an existing one in this case. So then you get a quick setup. It just det funker. Then you have the quick setup, which defines what key phrase you use to activate the custom command. In our case, MagicBoard. And then we have the builder action. This is the spot where you go in and create your custom action. So let's try to go in and build an action. Here you can see there's already a lot of built-in intents, but we want to build our own from scratch. So this opens up the Dialogflow console. Dialogflow is a third-party program that lets you build and design custom interaction in natural language without having to implement speech understanding from scratch. So now we opened our already existing MagicBoard program. And you see on the left here, you have something called intents. This is the different commands you want to send to your device and then get a certain response back. So let's see how let's go into building info. So here you can see you have a set of training phrases. These are different phrases you can use to try to get the show building info action to run. And so we have like different lists, like building view, building slide, change to building view, building. And then Dialogflow uses machine learning on these training phrases and manages to detect similar types of phrases. So you don't have to say actually exactly those who are written here. So since this is a really quick intro, we go down to the response. So if you just want your Google Assistant to just give you a text response, you can write one in the response field. But so here in this case, it would just say building info board, but we want some code to run behind it, so the view actually changes on our MagicBoard. So then we go down to something called fulfillment, which then connects to a web service. The intent connects to a web service, which you can then run some code on. So you press enable web service. Let's go to the fulfillment tab. So here you can either build your own web service from scratch, but in our case, because it's easier, we use the inline editor, which is powered by Cloud Functions for Firebase, and it comes with a lot of pre-written code, so it's much easier for you to work with. So I'll now just show you how you can map a given intent to a function that you write. So you have something called intent map, and then let's say we have the building info, which we just viewed. You just say intent.map set building info, which was the name of the intent, and then we match it to a function which we have made. So let's find this function. Yeah, here it is. So what this function does is it sends a message. So we use a function send message with the info building info board, and also you see it has agent add. This is what is returned back to the intent. So the text there is what the Google Assistant responds with either in text or speech after the code has been run. So as you heard in the demo, it responded with a text as well as running some code. So our send message function, let's see. Yes, here is send message function. It actually sends a JSON object with the command we gave in the send message call to an AWS bucket, so Amazon Web Service bucket. And then the value, JSON value, gets stored there. And then the MagicBoard, as long as it's not in sleep mode, continuously checks this bucket to see if the action is changed. And if the action is changed to, let's say, building info board, then it changes the view to building info. So that was the super short, yeah, there we go. Super short demo. So finally, I want to say, remember that the MagicBoard is an open source project, and everyone is welcome to go in and add any features they want to. And also, our project isn't made only by me and Kien, but a lot of other people who also contributed to this project. So yeah, thank you.